Hey everyone, so this video is on the three of the sorting algorithms covered in this course. It is going to cover the simple sorts, selection sort, bubble sort, and insertion sort, not necessarily in that order. Now, I'm going to be using for this video a set of animations that I created, and it is available to you to look at. So if you are interested in getting to this, this is the course site, of course, and if you go to the under resources, there's a link to something called My Animations, and in here you will find the actual animations I'm going to use to talk about these sorting algorithms. So let's get started. So in this, video is on the three simple sorting algorithms. I'm going to do a separate one on merge sort and quick sort because they're sort of bigger. And there's another sorting algorithm that isn't listed here that we also cover in this course called heap sort. And that one, you can find the video for that under the heap section because in order for you to understand how heap sort works, you first have to understand how heaps work. So if you go to the heap section, there is going to be a lot of talk about heaps and then eventually a video on heap sort itself. But let's get started. So let's take a look at bubble sort. Now, for each of these animations, and I apologize because some of these were made a while ago, and I have a new set coming in with where I've changed the underlying way I did it, but it's not ready, so I'm using my old stuff still. So the code on the side here, by the way, is in C++, is in C++, but there's nothing that there's nothing that is really different in Python. It's just different language, okay? But the algorithm is the same, okay? So anyhow, I'm going to slow this down. Let's get started. So bubble sort is called bubble sort because it bubbles the biggest number to the back of the array. So what's going to happen here is that there's going to be, you're basically always looking at two values that are side by side. If they are correctly ordered, like these first two are, you do nothing. But if you start looking at these two, 98 and 14, they're not in the right order. 98 is supposed to be bigger, so it should be on the right. What will happen is they will swap. And it does this, so this is how bubble sort works. Look at the first two, and it's correct. Look at the next two, is not, so they swap. Next two is not correct, so they swap. And what happens is as we do this, as we run through this array, the biggest number is getting bubbled to the end of the array. So I'm going to speed this up a little bit. So 98, you can see that's the biggest one, right? So it keeps getting moved basically to the end by continuous swapping. And if it goes through the entire array one time, that biggest number is bubbled to the back. Now, what's happening now is it's doing the same algorithm again, but now that 98 is not in the way, 94 is the biggest. So it's going to, once it passes through the entire array, that number 94 gets bubbled to the end. Now the next one is 92, I think. So 92 is being bubbled to the end of the array. And when it gets there, it's going to be placed at the end and so on. So this is bubble sort. Okay, this is probably the algorithm that you're most familiar with for sorting. And this is what it does. Okay. So the next sorting algorithm is called insertion sort. Now, oops, here it is, insertion sort. I'm going to pause this for now. Now, the way insertion sort works is it basically starts off by saying, okay, I'm going to pretend that my array is already sorted. And because it's already sorted, okay, so here we have a single element array, and that basic element is already sorted. So since it's sorted, we don't really have to do anything with it. It's sorted, okay? So what we are going to do is we're going to continuously place numbers into the sorted part of the array. So we treat this one element array as if it's already sorted. Then what we do is we start with the second element, and we're going to continuously try to insert it into the array as if that part of the array is sorted already. And it is, right? Because a single element array is sorted. So here we go. I'm going to play this algorithm. So it takes the 41 and finds the right place for it in the sorted array. Same with 46. 13. So here with 13, it has to move everything before I can put the 13 in. 21, same thing. It's just looking for a space to put that number into the sorted part. So you can see how this one is sorted from the beginning. And each time it's just looking for the right place to put the new number. So this one's going to have to actually move everything because it's at the beginning of the array. So this is the insertion sort algorithm. It inserts into an already sorted array. That's why it's called insertion sort. Okay. Now, the last of the simple sorts is called selection sort. It is called selection sort because what it's doing is it's selecting the smallest value and putting it into the back of the sorted part of the array. So right now the array is basically empty. There's nothing in the array. I'm trying to figure out what the smallest value is, and I'm going to put it into this blue square. Okay, so let me slow it down just a bit before I press play. So it's looking for the smallest. Every time it finds a number smaller than this number, it will put it to the front. Continue here. So every time it finds a number smaller, this min IDX value moves. And once it finds the smallest, swaps it into the back of that array. It's selecting the smallest value of the remaining unsorted values and putting it at the end of the sorted array. Okay, that's what it's doing. So this is called selection sort because it selects the smallest number out of the unsorted part of the array. That's why it's called selection sort. Okay. So as you can see, it sort of fills it up as it finds the next smallest. It'll put it into where this blue square is. So those are the three simple sorting algorithms. Now, of the three, insertion sort typically performs well, selection and bubble sort performs the worst. Now, I know that the Python code that I was playing around with, for some reason, the insertion sort was slower than the selection sort, but that's not usually the case. I suspect there's something going on because it's going through a Python interpreter. If you run the C code, which is closer to the hardware, insertion sort will outperform selection sort, and they both outperform bubble sort. Okay, but in any case, that's it for the simple sorts. By the way, when we say performs better, it just means that the constant is different. They're all still n squared. They still grow with an n squared pattern. So I talked a little bit about this in the video about analysis. So if you're interested in this, the last video on analysis, I actually run through some of the sorting algorithms and how much time it takes to run these. That's it for this video. Thanks, everyone.